questions. Do you not have my phone number?
No.
Well.
I don't use it.
Did you have a secret meeting that I missed?
No, she put it up on the board. See, corroboration. Make sure I wrote down mine instead of my husband's number, 319-750-5991.
Smile.
He would answer your questions too.
I got it.
Okay. So we're gonna pick up where we left off. We're gonna work the same problem sort of a different way. Now I am, whenever somebody comes to ask me for help, and some of you guys have seen this, a lot of times I will draw a picture, whether I need the picture or not. It's just habit. So I draw a picture, and we talked about hydrated salts. So the mass of a hydrated salt is given 8.320 grams. It happens to be nickel 2 chloride hexahydrate, so NiCl2.6H2O. And I'm going to go ahead and dilute it up to a volume of 250 with 4 sig figs milliliters. Okay, and I'm supposed to, again, you know, this is just how I work problems, but a lot of times I'll write a question mark somewhere on my canvas, and what I'm after is grams per liter, and I'm also after moles per liter. And we did this the other day. But keep in mind, sometimes you need to, I use the word be explicit. Sometimes you need to be explicit, sometimes not so much, but this would be grams of just the NiCl2. Those waters of hydration, what are they going to do?
They're going to go to the other.
They're just going to go to the other water. Taylor, you okay?
Yeah.
So, and then this one, this actually is molarity, and that would be moles of NiCl2 per liter of solution. And actually what we did, I apologize for it being segmented, but we kind of ran out of time. On Wednesday, what we did was we knocked out moles per liter of NiCl2, and then from there piggyback to grams per liter. I want to follow up with a different approach. So these were actually the molar masses you had on your previous slide. So when working a hydrated salt problem, and I kind of tease in working any problem, you can't go wrong knocking out the molar mass, whether you use it or not. Just keep in mind, whenever you do those molar masses, that, see if I can find my pen, that those units mean, this one, I'll pick on this one, that means there's 129.59 grams of NiCl2 for 1 mole of NiCl2. Even though I knock out the molar masses up here, I got to keep that in mind, but that's how I'm going to use it to my benefit. All right, so with all that in mind, we're instead of going for molarity first, we're going to go for grams of NiCl2 per liter of solution first. So if we, now this is the alternate method, I could simply put the mass of the hydrate, that's 8.320 grams of NiCl2.6H2O. So you should have a little place on your lecture slides to put this. There should be a box that says alternate method. So that 8.320 grams NiCl2.6H2O divided by, and this is where I like a picture, because if I had a picture, I'm like, oh, well, that was the mass of the hydrate. Oh, that was the volume of my solution. I like the picture. It's not a very pretty beaker, but it works. 250.0 milliliters of solution. Now, I also like that I have, this is my target, grams of NiCl2 per liter of solution. What units do I have? I have grams of NiCl2.6H2O per milliliter of solution. So I have to fix both of those. Now, on the previous slide I showed you, we can actually kind of look at the relative masses in, without the waters, we call that anhydrous. On the previous slide, we came up with the molar mass of nickel 2 chloride. This is the anhydrous, means without water. So 120, any questions for that number came from 129.59 grams relative to the molar mass of the hydrated salt, which was whopping 237.69 grams of NiCl2.6H2O. That's kind of their relative masses on a one mole basis. So what units cancel now?
NiCl2.
Yep. .6H2O. Easy for you to say. Very good. Grams of NiCl2.6H2O. Those units cancel. And now I have grams of nickel 2 chloride, which that's what I want, per milliliter solution. How can I introduce one more term to get units of liters in the bottom, liters in the denominator? Yep, times 1,000 milliliters over 1 liter. Again, if you just let your units kind of carry you away, do the heavy lifting, I got the units I want now. Okay, so grams of nickel 2 chloride hexahydrate cancel. And you guys told me this will make my milliliters cancel. I have units of grams of nickel 2 chloride per liter of solution. How many sig figs? I'm liking 4. Yep. So I would probably write it like you've heard me say before, I get tired at the end of a problem. I would probably count my sig figs, 8.14. I would probably write G/L NiCl2. That's how probably I would write that. Yeah. And this one, actually, we could go to molarity now using simply the molar mass of NiCl2. Okay, one more problem in this part. So I'm going to draw a picture. My beakers, I gotta work on my beakers. Wait, did I have them? Okay, so here we have a solution of acetic acid. You're gonna see it on the next slide, but I'm gonna leave no number unturned. I'm gonna leave no number unpacked. So, I'm gonna ignore the formula for acetic acid for now, but 76% acetic acid, 76.0% acetic acid. That means there's 76.0 grams of acetic acid in how many? What do I put in the bottom?
100.
Very good, 100 grams of
Solution?
I'd go with solution. Yep, very good. I unpacked it. It's a puzzle piece. I put it in the margins. I might need to flip it as I work this problem. Okay, so let's unpack 1.07 G/ml. I'll get you started. 1.07 G. Now, is that grams of acetic acid? I'm going to ask for a show of hands. How many people, acetic acid or solution, how many people think that's grams of acetic acid? How many people think that's grams of solution? You're totally right. And I'm going to be, the word is explicit. I'm going to be explicitly label that so I don't get confused. You're right. That's grams of solution. SOL''N. What goes in the bottom? I heard 1 milliliter. And then what would it be of? Yep, solution. Yep, very good. So I got something about solution over here, and here I got a link between solution and acetic acid. All right. So what is the molarity? So question mark, molarity. I would unpack what that means. That means moles, in this case, of acetic acid per liter of solution. That's what I'm after. Wow. And notice I don't have a volume of solution or anything. Okay, but this is my target. So let me go ahead. What did I say? When in doubt, use the knock out the molar mass. So I'm going to somewhere up here in my puzzle piece, we can take, we can knock out the molar mass using the periodic table. I'm going to put MM, meaning molar mass of acetic acid, and it will have units of, what will the units be? What are the units of molar mass? Yep, grams of acetic acid, yep, per mole of acetic acid. Yep, so that's another puzzle piece. I got 1, 2, 3 puzzle pieces, and here's what I'm after. Okay, so this slide knocks out what we just did. I don't know if you fill this in, but that's unpacking the weight percent, grams of acetic acid to grams of solution, and it's also unpacking the density. Well, somewhere can you see in these puzzle pieces? Let me draw a different, let me get a different color. See what this one is? You see where I'm going with that? Liter of solution, well, it's not liter, but it's milliliter of solution. Okay, I should have used two different colors, but hopefully, well, two stars here. Okay, so that's kind of things you're laying out, okay? I'm gonna string up those three puzzle pieces. I need the molar mass. Of course, we've been talking about this. We use a periodic table. The formula for acetic acid has 2 carbons, so we take 2 times 12.01. There are 4 hydrogens, so we'll take plus 4 times 1.008. And there are 2 oxygens, so we'll take 2 times 16.00. So now I can even go ahead and put we said the molar mass then is 60.05 grams per 1 mole. Specifically 60.05 grams of acetic acid per 1 mole of acetic acid. Cool. All right. Okay. So it's almost like magic. Not really like magic. And you don't have to have these terms in this specific order. But if I start with this term, this was the weight percent.
Will you be able to go back?
I can go back. So unpacking the molar mass, that's 60.05 grams of CH3COOH for 1 mole of CH3COOH. One of the questions sometimes I get from students or from people, you're like, wow, why didn't they like combine the carbons and combine the oxygens and combine the hydrogens? Why didn't they just combine that? And sometimes you'll see the formula for acetic acid written that way. But this actually gives it a little more structure. We see the CH3 group is what we call a methyl group. The COOH actually is what we call carboxylic acid group. So you kind of get, if you know a little bit about chemistry, like, oh, I bet that's some sort of, 2-carbon carboxylic acid. Okay, so there's our 3 puzzle pieces. Bless you. Now, if I start with this one, and I can't remember the order of my slides. This is simply the grams of acetic acid over the grams of solution. How can I use the molar mass to get grams of acetic acid to cancel? We left with moles in the numerator.
Acetic acid over.
Yep. I'm going to put 1 mole of CH3COOH over 60.05 grams of CH3COOH. So now my grams have canceled. I used my molar mass to now I have moles of CH3COOH per grams of solution. But I want moles of acetic acid per liter of solution. So how can I use density to get units from grams in the bottom to milliliters in the bottom?
1 mole solution over 1.07 grams.
Yes. Well, wait. So I want.
Or you're going to put it in like that. Because if you're doing, because you want the grams to cancel, so you have to put the grams on.
Those aren't canceled. Wouldn't it be the 1 grams of 1
Yeah.
liter?
It would be just like this, the unflipped
Okay.
version, wouldn't it? Because I want grams of solution to cancel. Yep. So I use the unflipped version. Yep. The reason I did that is because I had grams of solution in the bottom here. I wanted gram solutions in the top there, and then they'll cancel. We have milliliters of solution in the denominator. So right now we got moles per milliliter. How are we going to do one more term? Yep, 1,000 milliliters over 1 liter. How many sig figs?
3.
I'm liking 3. So with 3 sig figs, you're looking at 13.5 is your number, and I would probably do, like you see in parentheses down there, I would just put 13.5, a big M, not a small m. Big M means molar, 13.5 molar, and then I would put CH3COOH. Okay.
How many times you said COOH? You think I would put it C?
CH3COH.
I keep on hearing CH3OOH. Changes everything.
Okay, so the Alta homework, as you know, is due Monday. Well, maybe you didn't know, but it is.
And then unit, the
sheet.
part 4.
Oh, yes, thank you. And then the hydrated salt is also due Monday. Yeah. Thanks for reminding me. Okay, on to part 10. Dun, dun, dun. All right, so actually, one of the calculations that we did for yesterday's lab, we're going to see kind of pop up here. In this class, we do, I guess they're called conversions, but if you look at the units of anything, you can know how you can use it as a tool to get between units of things. So if you have concentration given in grams of solute per liter of solution, you can go back and forth between those two quantities. Molarity, of course, is moles of solute per liter of solution, so you can go back and forth between those two. And mass percent, we know we can go back and forth between grams of the solute and grams of the solution. So let's kind of see what that looks like. And again, we're going to definitely do the unpacking here that I've been talking about. So, and I probably wouldn't draw a picture for this one. You're like, why not? I don't know. But I would unpack it. We are given the solution concentration of a sodium chloride solution as 14.3 grams per liter. I'm going to unpack that. What volume, so question mark milliliters, what volume or question mark liters will contain 22.3 grams of NaCl. My first term is going to be 22.3 grams of NaCl. Oh, here's my unpacking. So keep in mind that the 14.3 G/L means 14.3 grams over 1 liter of solution. It is a puzzle piece. And we know what we can do with puzzle pieces. We generally can turn them 4 directions. Okay. Okay, so keep these in mind. We can call the first one A, the second one B. In the next slide, I'm going to ask you which one we're going to use, A or B. So I told you to work this problem. My first term, the way I do it, is going to be 22.3 grams of NaCl. Okay, that's going to be the first term. Now, we need to multiply by something where grams cancel and we're left with liters. So how many people think we're going to use A? How many people think we're going to use B? Yay, me too. And that's it. Units of grams of NaCl cancel. We're left with liters of solution. You guys probably would have told me 3 sig figs. So when you take 22.3 and you divide by 14.3, you get 1.56 liters. On my intro to Gen Chem class exams, this is the sort of problem they get. This is not the sort of problem you get. Okay. All right, not bad. I do too. Do you have those problems? So we're switching up from NaCl to K2Cr2O7. That's the different solutes. Okay. Notice the big M. What does the big M mean? Molarity. Yeah, molarity. I'm going to unpack that, I think, on the next slide. If I don't, I'm going to unpack it. What number do you think I'm going to start with? Yep, that's what I would do. The 0.015 moles over 1. And we're after volume. So if we unpack molarity, 0.255 big M, in this case, means 0.255 moles of K2Cr2O7 per 1 liter solution. And we can take our puzzle piece and flip it. I don't think we can take our puzzle piece and go a quarter turn, but 2 quarter turns. 1 liter of solution will contain 0.255 moles of K2CR2O7. I'm going to call the top one A, the next one B, the bottom one B. You guys told me that I'm going to start with 0.015 moles of K2CR2O7. I would put it over 1. How many people think we're going to use the first one, A? How many people think we're going to use B? Can't fool you guys. Yes, we're going to use B. Rounding. How many sig figs? How many people think it's 3 sig figs? How many people think it's 2 sig figs? 2 is right. It is just 2. There's only 2 sig figs because this is kind of a placeholder. So nope, but yes, yes. 2 sig figs, and of course there's 3 there, but we're conservative. So 2 sig figs, oh sorry, my bad. The answer asked for it in volume in milliliters, sorry. Now on a test, sometimes students will say, so I've introduced a term 1,000 milliliters over 1 liter. On a test, if I didn't say milliliters, you could leave it liters. Okay, so 2 sig figs, you're looking at 59 milliliters. Very good. Not too bad. Okay. So this is kind of this is along the lines of what we did, but we're using molarity now in order to get from volume to moles. A little bit ago, we used molarity to get from moles to volume, okay? So I think I've stopped unpacking numbers now in my slides. But I bet you're good with this. That would mean 0.108 moles of CaCl2 per 1 liter of solution, right? Oh, I did unpack it. So what's my first term going to be? Here in a minute, on the next slide. Yep, I would start with the 75.0 milliliters of solution. 75.0 milliliters of solution. You got it. And I'm going to use that to my benefit. So I have a little flow chart here. I'm going to have to go from milliliters of solution to liters of solution because the molarity I unpacked is in moles per liter. So I have to get from milliliters to liters. You guys know how to do that. And then I can go from liters to moles using the molarity. Okay, this is kind of a strategy for how to work it. So you guys told me put 75.0 milliliters solution over 1. Now my next term is going to be, like you see the strategy, to get from milliliters to liters. So how does that look? Yep, I bet you guys agree. 1 liter over 1,000 milliliters. Perfect. Now I'm ready to use molarity, and I have liters on the top, and I want liters to cancel, and I'm going to left with moles. Yep, so I use the non-flipped version of the molarity, exactly. 0.108 moles CaCl2 per 1 liter of solution. What are my units now? Yep, they are moles of CaCl2. Perfect. So am I done? I think so. How many sig figs?
3.
It is 3. Why is it 3? Yeah, that trailing 0 after the decimal. Yep, it is 3, and there's 3 here. So to give it 3 sig figs, notice that this is the number we report. The 8 is significant, the 1 is significant, and that 0 after the 1 is a trailing 0 after the decimal, so that gives us 3. Not bad. All right. So, I don't know, I might draw a picture for this one. Depends on what kind of mood I'm in. So here I have a solution of glucose. The formula for glucose is C6H12O6, okay? And notice that they told me that the volume of my solution is 125 milliliters. They told me the molarity of my solution is, I'm gonna go ahead and unpack that, 0.432, and that would be moles of C6H12O6 per 1 liter of solution. So question mark is grams, question mark mass. It's like, what did I say? When in doubt, use it. Molar mass. Here, I think on the next slide, I can use a periodic table. I can come up with the molar mass of C6H12O6, and that would be the grams of C6H12O6 per 1 mole of C6H12O6. So that's a puzzle piece, that's a puzzle piece, and that's a puzzle piece. Can't remember how my slides go.
You have a flow chart on the next one.
Thank you. I have a flow chart on the next one. Thank you. So we got this 125 milliliters, and we're going to use probably molarity next. Okay. So it's like we did before. You have to go the milliliters to liters, and you guys know how to do that just fine. So once we get it to liters, now I can use molarity to get to moles, right? That molarity to get to moles. And then once I have moles, we've done that a lot. We could just use molar mass to get to grams. So that's kind of something we've been using before. Okay, so my first term is going to be 125 milliliters over 1. So now how do we get to liters from there?
1 liter over 1,000.
Yes, 1 liter of 1,000 milliliters, perfect. Now, how do I use the molarity to get to moles? It's unflipped, yes. Just like that. 0.432 moles of C6H12O6 per 1 liter of the solution. That's molarity. So let's see. Units wise, our milliliters have canceled, our liters have canceled. We left with moles. How do we get from moles to grams? Using the molar mass. And this is one where actually, my bad, I did not show you how we use the periodic table to knock out the molar mass of glucose or sugar. It's 180.16. My bad. This, we would have used the periodic table. This is the molar mass. P table. But do you see how we use the molar mass? Because we wanted units of moles to cancel, we left with units of grams. And that's it. That's our target. How many sig figs? I'm liking 3. Yep. So, dun dun dun. 9.73 grams of C6H12O6. And let's see, we're getting kind of into practical regions, practical problems. Because it's possible that if you're a lab tech or a chemist or whatever, you need 125 milliliters of a particular molarity of a solution. And we have just figured out how you go back to the balances and weigh out the mass of that solute to give you that molarity at that given volume. Yay! That's it, Mom. So this homework, so 9, 10, and the hydrated salt are due Monday, along with looking at those problems at the end of the unit to see how those are coming along for you. Okay?
Rough.
What's that?
Rough.
Rough break. All right. Let me know if there are any questions along the way. Yes, I do take texts too. Feel free to text me. Sometimes I'll get that